In this lesson, we discuss Angela-Sun's small autonomous anti-DDoS system called A2D2 for defending against DDoS attack. It utilizes a Linux Firewall Rate limiting and class-based queuing, CPQ for short, to deal with various types of attack traffics, including ICMP, UDP, and TCP. We'll see how effective different mechanisms dealing with those attack traffic. It also implemented a snowed flood preprocessor to detect the subnet flooding. And it implemented a multi-level rate limiting scheme to adapt to suspicious traffic, because sometimes we don't know for sure this is a real attack. Could be a legitimate users. We see in the next lesson how to effectively using this different filtering technique to deal with various DDoS attack traffic type. At the end of the lessons, you will learn the basic IP table command for setting up class-based queuing or rate limiting technique to deal with suspicious traffic and or DDoS attack. You will understand the effectiveness of those different schemes in dealing with DDoS traffic pattern. Angela built a small-scale DDoS defense evaluation testbed. As you see here in the picture, he built a small attack network using Linux machines with stock drawer software from University of Washington, implemented for launching the DDoS attack. I believe the one coordinator for attack agent here. And so that, and on the right side, you see there's a site with a DMZ firewall and enhanced snowed IDS with a subnet flooding processor she implemented herself. To test the effectiveness of this various attack scheme, defending against DDoS attack, she set up a few real servers, 3 of them, real player client, to launching the real-time streaming video retrieving from the real server, a real player server hosted in the DMZ zone subnet. The metric for effectively for the A2D2 system effectiveness, including number of packet loss, retransmission request generated, and how much of those retransmission response is coming back. Here we show the rate limiting setup using the IP table command. The IP tables command with -n option is used to set up a different kind of chain. Here we set up 3 different level of rate limiting. So level 2, level 1, level 0. For level 2, we use -a to specify the join of the root in forwarding root. The rate limiting is limited for traffic that to that chain to be 100 packets per second, and we use that -m limit option to specify this kind of rate. When those rates are exceeding the packet coming to the chain exceeding those volume, the packet in that chain will be dropped. For level 1, we specify the rate of 50 packets per second, and any packet got routed to level 0 will be dropped. The last rule say in forward chain, if we see any packet with a source IP address 12.23.34.45, we'll route them to level 1 chain subject to the rate limiting. And if the traffic from that source is exceeding 100 packets per second, the remaining packet during those periods will be dropped. So there's a window. They can only accept that 100 packets per second. We use a Snow preprocessor to count the accuracy rate from a subnet and switch the suspicious traffic to level 1 if over that 30-minute period continually to have the 100 packets per second. And once go to level 1, they only allow 50 packets per second. Normal Snow IDS consists of rule-based kind of detection engine. They check on all the Snow route. If they match, the packet got dropped or generate alert. Or the other thing, if they you try to extend the feature, what you can do is allow programmer and designer to use their API to add program into their packet processing, normal packet processing, and that can be done before the rule check. That's pre-processing, or after all the Snow rule is checked. That's post-processing. The customized program can be inserted into before the rule engine or after the rule engine to the actual working system. Here it shows a set of files to prepare when Angela implements the subnet network flooding detections. If you are interested, you can actually visit her master thesis for more detail. Here we show the A2D2 adaptive multi-level rate limiting system. The report C program will run and listen to the Snow host to accept the Snow alert messages generated by the preprocessor, and then forward this rate information to the process running on the firewall, and the process will run a rate if.pl per scripts, listening to a particular port, and the program report.c can send these messages to that particular port. Once the rate if.pl receives the request, it will passing the message, take out the subnet information, and then looking at the firewall rule, decide whether to change, update, and insert the rule, changing from level 1 to level 2 to level 1 to level 0. When the traffic exceeds certain threshold, the packet from the subnet will be put on rate limited chain, and if the traffic level persists, you go to the next level and so on until it was blocked for a short period of time, and then blocked for a longer period of time or even days. Here we show the implementation and processing of class-based queuing, CPQ for short, available on Linux Firewall. First, the packet will be classified. We need to classify the packet based on their type or header content, and then set the mark value in the header. Set the different mark value based on the protocol type. And once that further down the road, when we actually start doing the processing, that can be processed based on the mark value. For example, here HTTP is mark 1, HTTP mark 2, and NNTP mark 3, and ICMP mark 4. We can specify, we then specify these 4 different queues with different bandwidth quota to serve the packet and mark with those mark number. Thus, the packet with a different protocol will be treated differently with a different kind of bandwidth. Next, we will show the IP table command for actually setting this CPQ up. Here, we show the IP table command to mark different protocol and services traffic with a different mark value, 1 to 4. -P specifies the different protocol, -O, as before, specify the outgoing interface device. Here we use a $ DMZ to represent whatever the DMZ interface. It will be outbound to the internet. DMZ outbound to the DMZ subnet. -j mark indicate the jump options. We consider to be like a loop, subroutine. It will be marking the packet, changing the bit field in the IP header, TCP header. And with a dash mark with a number, the N will be used to set the mark field. Here we show how to use a traffic control, TC command, to set up the queue discipline. Please check the related TC main page for detailed parameter specifications. After creating the rule class and initialize with those parameters, we describe in this script, we describe add class subroutine and allow to be shared by different setting different classes. It takes in 6 parameters. The first one, $1, is parent class. $2, which is convention for shell script. $sign represents the second parameter, which is class, the particular class ID. The third one is high bandwidth. The second one is the low bandwidth, and the lowest bandwidth, available bandwidth for the class, and then handle value, and then last one is style. And actually, the style is the mark value. The mark value IP table command generate in the we set up in the previous slide. Here we show how the 4 traffic class for ICMP, Simple Mail Transfer Protocol, FTP, and the combined of web and real-time streaming services. How are they generated? First, 10.1, 10:1 is the root class ID. The second parameter is the second parameter is 10:100. 100 is the SMB class ID. SMTP is 10:200. FTP is 10:300. World Wide Web, HTTP, and the real server traffic is 10:400. The bandwidth allocation for these 4 different groups are 5% for the ICMP, 15%, and 10% and 70% respectively. So we give more bandwidth for the client traffic, which is web and the real-time streaming services. The actual calculated bandwidth is 10 megabit multiplied by the number, those percentage numbers. So the ICMP will have the high bandwidth no more than 512 kilobit per second. And the email is 1.5 megabit per second top, and then the email is 1.1 megabit, and the www, World Wide Web, and real-time streaming has 7.1 megabit per second kind of bandwidth. So the last parameter to add to the add class function is the style or the mark value.